Welcome. So in this part, we're going to be sketching a cubic in this form right here. Now to do this, what we need to do is actually factorize it. So we're going to go through that long process of turning something that looks like this into its factorized form, which means step one, we're going to have to use the factor theorem to find a factor. Then we're going to have to perform polynomial long division. Then we're going to have to write the polynomials in factorized form. And then we're going to have to identify the x-intercepts. So it's going to take some time, and let's go through this example here. The first thing I'm going to do is just let y be equal to p of x. And that way, I don't have to keep on referring to this. I can just refer to it as p of x. Now, step one. Step one is going to be using our factor theorem. Now, to do this, we're just going to consider factors of 6 and sub those in. So factors of 6 are what? It's going to be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. So let's begin by just subbing these in and see what happens. So let's start with 1. So p of 1 is going to be what? Well, I've got 1 cubed, which is 1, plus 2, minus 5, minus 6. Now, looking at this for a time being, it's clearly not going to be 0, is it? So let's go to our next one, negative 1. This is going to be negative 1 here because negative 1 cubed is negative 1. This will be still plus 2. This will be plus 5. And this will be minus 6. Now, this looks promising because minus 1 plus 2 will be, positive 1. Then plus 5 minus 6 will be negative 1. So that's going to be 0. So this is where we say hooray, because what this tells us, because we got 0 out here, therefore x plus 1 is a factor. So the fact that I could put negative 1 into this and get 0 out tells me that x plus 1 is a factor. So that's step 1 done. Now we move to step 2, which is perform polynomial long division. So let's kind of come down here. Let's go 2. We're now going to do some division. So I've got my factor, which is x plus 1. And let me zoom in here and let me do some polynomial long division. So what was the actual numbers? What were we given? Let me just do this. So I'm just going to write this down. It's x cubed plus 2x squared minus 5x minus 6. Okay, let's come in here. Let's see how we go. Let's grab green. X times what is x cubed? X squared. X squared times x is x cubed. X squared times 1 is plus x squared. This is going to be 2x squared minus x squared, which is x squared. I then carry down this minus 5x. X times what is x squared? That's going to be plus x. X times x is x squared. X times 1 is plus x. I then subtract. So therefore, this is going to be negative 5x minus x, which will be negative 6x. I then carry down this negative 6. Then I go, x times what is negative 6? Is it going to be negative 6x? It's going to be negative 6. Negative 6 times x is negative 6x. Negative 6 plus 1 is negative 6. I then go minus. This means I'm going to end up with 0 here. And remember, we had to end up with 0 here because x plus 1 is a factor, which means it goes into it perfectly. So that means at the end of all of this, I can say that I have x plus 1, and then what my quotient is here, x squared plus x minus 6. That is what I have discovered. So we have performed polynomial long division. Now let's do the next thing we have to do here. The next thing that we have to do is factorize the quadratic. Factorize quad. Now, in brackets, I should say if possible, because sometimes this ain't possible. So let's come here. So I've got x plus 1, x squared plus x minus 6. And now what I'm trying to do is I'm trying to factorize this thing right here, this quadratic. Well, to do that, I have to go, I need a product of negative 6. I need a sum of 1. What are those two things going to be? Well, it's going to be 2 and 3, right? And it's going to be positive 3, negative 2. Yes. So that means what I'm going to end up with here is x plus 1 x plus 3, x minus 2. So that's what I'm going to end up with. So x plus 1, x plus 3, x minus 2. Now, I can figure out what my x-intercepts are going to be. My x-intercepts are going to be, wait for it, x is going to be equal to -1, -3, and 2. Now, I can sketch this thing. So I can come over here now, and I can say that I have a point at -3, at -1, and at +2. So that means I'm going to go up. Let me do this in orange. I'm going to go up because it's positive, and then I'm going to go down, and then I'm going to go up again. Remember, do not worry about where your turning points are. You're not going to be judged on those. You can't find out what they are without the CAS. So we don't expect you to be drawing your turning points correctly. Just try to draw your graph as smoothly as possible. But remember, your turning points do not matter. That's really important. And I think each question in the exercise says, don't worry about finding the turning points. You can't do that until you know calculus. So this is going to be -3, 0. This will be -1, 0. And this will be 2, 0. And that's generally what your... Whoa, what happened there? And that's generally what your graph is going to look like. What is happening here? So -3, -1, and 2, you can see there's quite a few steps there. So the 4 steps that we did there are the 4 steps that we did here. That's how you do it. So a bit of an involved process. Can I remind you yet again that in the exercise they talk about sign diagrams. You do not need to do that. You do not have to worry about sign diagrams. So that's how you would do these types of questions. So follow these steps and you should be fine. See you in the next part.